Thanks for asking me here today to give a presentation. My background is I'm a landscape architect, not an arborist or a soil scientist. I've had a lot of experience in designing streets for trees and urban spaces for trees. But also I'm drawing upon my PhD research topic, which I finished about 3 years ago, which was really looking at more sustainable ways of planting trees in cities. I don't know if you can read this, but this quote sort of summarises really what I'll be talking about today. This is by James Urban, who was mentioned earlier as a United States landscape architect, who is really an expert on trees in cities. So he's really saying that the way we've been designing cities and trying to accommodate trees in cities is wrong. We have to do something, we have to adopt a different approach. So I'll briefly be talking about needs of urban trees, what are the urban tree issues, and I'll be talking about what I call tree literate design principles. How can we design around the biological needs of trees, and also provide a brief overview of best practices. I'll be covering some of the same ground that Andy talked about before, but I hope I can sort of reinforce the messages that he was trying to deliver. My starting point is really urban tree benefits. We all know that trees provide a wide range of benefits to the city. The trees and the urban forest are a form of green infrastructure. They provide multiple benefits. Some of those listed there, I won't go through them, but they're tangible benefits that we can actually quantify and value. So my first point really is that trees should be an essential rather than optional part of the city. And the research also shows that large, mature, wide canopy trees maximise all of these benefits that I mentioned before. So we should really be trying to plant the biggest tree possible for a given site. And we should be providing the conditions will allow trees to survive and grow to maturity so we can maximise the benefits they provide. Just briefly on planning issues. You all know that trees are often left to the last step in the planning and design process, and that really they're squeezed into whatever space is left over after the engineers have had their go and everybody else has had their go. These problems are becoming worse now with urban densification. It's becoming more and more harder to plant trees, especially large trees. We've got urban infill. I'm from Adelaide. We have a lot of 2-for-1 subdivisions. You lose existing tree cover, and you lose planting space on private land. New development, there's always that pressure to maximise lot yields, which leads to narrow verges and reduced tree planting opportunities. So I think we really need to give trees equal status to other forms of infrastructure when we're planning and designing cities. Urban tree needs. This is pretty much a dumbed down diagram which I use to present to landscape architecture students. There are three basic. The needs of a tree in the city are the same as those in the forest. There's no such thing as a street tree. There's only trees which are taken out of the forest and grown in streets. 6 basic requirements, plus adequate soil volumes. So this is what a lot of landscape architects often forget, that to grow healthy, long-lived trees, we need to design around the biological needs of the tree itself. Landscape below ground. Particular emphasis needs to be placed on the often forgotten landscape below ground. Others have mentioned this. We have a better understanding now of the interactions of tree roots, soils and water in urban environments. And we also have a new model of tree root morphology. So there's that image there of the elm tree that was air spaded and excavated at the Waite. Required soil volumes, this was mentioned earlier also. There's a direct and intuitive relationship between the size of a tree and its below ground growing space. And a tree needs adequate soil volume to provide the resources for it to grow to maturity. As somebody mentioned before, what information there is on calculating soil volumes. In my thesis, I sort of summarised a lot of the research on that topic. So I won't go into detail, but there are 2 main approaches. One is empirically based observations, where people are looking at existing trees, how big they are and how much soil they occupy. And the other is, as Andy mentioned, calculating soil volumes based on the water demand of trees. So a tree needs a certain volume of soil to provide it with a certain amount of water. These estimates tend to vary widely due to differences in the assumptions in the research methods, and also the ability of tree roots to adapt to urban situations. So trees can colonise a lot more soil than you might think they've been allocated in their sort of planting space. Somebody also mentioned earlier about James Urban. He produced a widely published graph which relates tree size to soil volumes. It was based on observations for a large number of trees in US cities. So this sort of graph, there's no way we can really ever provide the volumes that a tree needs in a tree pit, but it does highlight the fact that the way we're planting trees is well below the optimum that we should be looking at. So you have the open planting situation. Crawl and Crawl and others have identified the various requirements you need to plant a tree and allow it to survive. In the open planting situation, you have a sort of best arboricultural practice tree pit, which you're all probably familiar with. A wok-shaped hole, a firm base, so you don't get any root collar rot. A watering basin around the tree and mulching, and staking as optional, sort of mainly as a de facto tree guard rather than actually providing support for the tree. But in cities, the situation is very different. You've got a very stressful planting situation, a very stressful environment in so many ways. So urban trees face a dilemma. As I said before, the city is a hostile environment for trees in which it's hard for them to actually satisfy their biological needs. And this is often exacerbated by inappropriate planting practices. So the sort of three main things. We're planting trees in undersized tree pits. And these pits are dug in highly compacted soils, which are hostile to root growth. And they're surrounded by hard, impervious surfaces, which limit water, oxygen, and nutrient exchange. So these tree pits may meet the short-term needs of the tree, but they become tree coffins if the roots are confined to that space. And a lot of research has shown, as well as observation, shows the effects of restricted rooting volumes on tree health, longevity, mortality, etc. In my own research, I carried out an online survey of street tree practitioners around Australia, mostly in sort of local government, and the thing that kept coming through all the time is that lack of space is the main constraint on tree planting in urban areas. So we need to provide adequate space for trees above and below ground. And I quite like this image here from the Bankstown Transport Interchange. It shows somebody's actually thought about a tree, how big it's going to grow, a ficus. They provided space above ground for the tree, and they provided a soil volume below ground for the tree. Be easy just to plant 3 or 4 trees in that same space. And they've also provided permeable paving. So I've sort of summarised a number of what I call tree literate design principles. One is to recognise the true value of trees at the strategic level, in the sort of local government and the state government planning process. Second is to give trees equal priority to other forms of infrastructure in the decision-making process. Third is it's the old one about selecting the right tree for the right place. But I'd also change that slightly to say plant the biggest tree possible for the available space. Fourth, design around the biological needs of the tree. And that involves a couple of things. One is providing the required space for the tree above ground, and also providing the required space for the trees below ground. And then also providing trees with the necessary resources for growth. And the sort of main one we're worried about there is water. And also, as part of that overall sort of approach, is minimising tree infrastructure conflicts. And if you provide adequate space for trees above and below ground, to a certain extent, you're actually going to help address those issues. So I like to use this term, thinking like a tree. When planning and designing urban spaces, we should try to think like a tree. So as a landscape architect or designer, we should be thinking about what are the needs of a tree. And I've sort of come back once again to James Urban. He has this sort of useful image where we have to consider all the major parts of a tree when we're designing. The tree crown, how much space it's going to occupy, the trunk, how thick it's going to be, basal flare, how the tree relates to the ground surface around it. The zone of rapid taper around the tree, which is sort of the structural root zone, and the actual root zone itself, how much space below ground does the tree need to survive and grow. So now I'll get into an overview of design practices. The first one is how do we create space for trees above ground? When I say above ground, I mean above ground and up on the actual ground plane itself. So my PhD dealt mostly with street trees, so a lot of this stuff relates back to how do you design streets to accommodate trees. So we can design streets and other urban places, or we can redesign them or reconstruct them to provide more opportunities for tree planting and more individual space for individual trees. And the whole range of practices there: enlarged planting spaces, widening verges, providing alternative footpath layouts, planting trees in other locations than we normally would, taking advantage of opportunities within the city for planting trees where there is space available, and particularly creating space for trees in new urban developments. So enlarged planting spaces. As I said before, trees should be given equal status to other elements of the design of, say, a street. They should have equal sort of status to other things like the demands of traffic and pedestrians and underground services. So we should try to allocate the largest possible space above ground, which maximises the soil volumes and also maximises the amount of porous space and also increases separation from hardscapes. So come back once again to that photo about providing maximum sort of planting space in the actual design of the streetscape. Another example from South, I didn't mention I'm from Adelaide, so I've tried to use some examples from Adelaide because a lot of the best examples you see of tree planting and design, they come from Melbourne. So once again, giving the tree more space, reducing the footpath, providing permeable surfaces. Verge widening. We can widen the verges by doing things to streets, removing parking lanes, narrowing carriageways. We have to compete with all the other demands in the street, such as bicycle lanes. And obviously Swanston Walk in Melbourne is a good example where you've given the pedestrians and trees a bit more priority over traffic than usually occurs. Alternative footpath layouts. We don't have to have that traditional footpath on both sides of the street. We can have reduced footpath widths down to the sort of minimum requirements. We can eliminate footpaths in some situations. We can have a footpath on one side of the street only, particularly in sort of new urban developments. We can have footpaths adjacent to the kerb we can have footpaths adjacent to the property boundary instead of the kerb. We can have we don't have a straight footpaths, we can have meandering footpaths. We can look at alternative tree planting locations. We usually plant street trees in the verge adjacent to the kerb. You can also plant them sometimes on land adjacent to the street itself, if there's a particular volume of soil there. Things like Hyde Park in Sydney, where there's no street trees as such, but you get the borrowed landscape from that public space. And kerb build-outs in the parking lane and medians, and reclaimed urban space. And also, if you've got the space, you can plant trees in groves or clusters. So planting in the parking lane. Parking lanes often offer sort of a lot more space than footpaths for planting trees. If you plant the trees at grade, it's quite easy to redirect stormwater into the tree pit. But often you've got to balance that against loss of parking spaces. Median planting. Trees can be planted in traffic medians, in arterial roads and boulevards, provided you've got certain sort of criteria being met, sufficient width, appropriate tree species, etc. But in South Australia, and also I understand in Victoria, that traffic authority requirements are becoming more restrictive. In fact, if you follow the letter of the law, you wouldn't be planting trees in medians at all, probably. Grove planting is another example from Melbourne, where you might find spaces in the street or the landscape where you can plant trees in groves or blocks. Often there's areas of underutilised leftover space. Maybe when engineers redesign a road junction, there's bits of sort of residual space left over. And trees planted in groups often better reflect their natural forest environment and provide opportunities for improved soil conditions and water management. Opportunistic planting, I mean, this is similar to that last slide, but often there are leftover places in the city where you can plant trees. So one example, in Adelaide, you've got whole suburbs with traffic calming measures, road closures. There's a lot of space there where you can actually plant trees where the roads have been closed off. And also you can integrate that with water sensitive urban design and other sort of improvements. Alternative street templates, which I've called it, which is really an alternative designs to streets. You don't have to have the traditional street down the centre of the road reserve with footpaths on either side. I mean, in theory, you can introduce curved roadways that gives more space to plant large trees, and also can be integrated with water sensitive urban design practices. So that's one from Seattle, where they've sort of reconfigured streets mainly to provide sort of stormwater management. So obviously that applies mainly to sort of in residential areas rather than sort of informal formal streets. The offset template, that's what I'm saying, you don't have to have the carriageway down the middle of the road, you can actually have it offset to one side, so you have a narrow footpath on one side and a larger space on the other side where you can plant larger trees. And this is an example from Parkside in South Australia. In this situation, they're actually lucky because they had a very wide verge on the street to start off with, due to underground sort of underground drainage. So often in narrow streets, you can't really necessarily plant trees on both sides of the street. You can allocate the space on maybe one side of the street. In creating space in new developments, we need to find better ways to integrate large trees into high density building typologies. I'm showing here, this is research by Mulholland for the Brisbane City Council, taken a few years ago with Lyndall Plant. He's looking at ways of integrating large shade trees into high density developments. Often with new development will require a certain amount of open space, but we should also be providing a certain, what he calls a sort of deep planting area. So we should be providing a permeable, high volume, large soil volume, free of obstructions, where somebody can plant large trees. And it's given examples here where you can actually redesign a potential development to actually, without reducing the lot yield, actually create larger spaces for trees. Next year I'm looking at is creating space for trees below ground, which really sort of relates to what we're talking about today. So increasing available soil volumes is essential to growing healthy long-lived trees. There's a whole range of practices which include increasing soil volumes using either larger tree pits or shared soil volumes. And the second group of practices which really relates to how do you extend the rooting zone of trees beneath the surrounding hard pavements. So a number of options there which were discussed earlier. One is suspended pavements, structural soils and plastic root sills. Maximising tree pit size. So a number of authorities have developed minimum soil volume standards for urban tree planting. A particularly useful one is the Landcom Street Tree Design Guidelines for New Subdivision in New South Wales. That specifies required soil volumes for small trees, medium trees and large trees. And apparently a common requirement in a lot of North American cities is a minimum volume of 30 cubic metres of soil per tree in a single planter or 15 cubic metres in a shared trench. And if you go on the internet, there's a site called Deeproot blog. There's a lot of information there on required soil volumes, including the actual soil volumes provided in US cities, and also provides an overview of all the various cities that actually do have requirements for minimum soil volumes. So that's quite a useful resource. It's a Deeproot blog. It's actually, I think it's run by the people who produced the silver cell plastic cell system. Another option is to provide shared soil volumes. So trees have been shown to benefit from shared rooting zones, which is how they grow in nature, in the forest, in terms of the rate of growth and the uniformity And also apparently you don't need as much soil in total, because if you're sharing the volume, you need less per individual tree. So in urban situations, which is happening more and more often, as trees can be planted in linear trenches or with trenches connecting the individual tree pits. And these sort of trenches are usually about 2 metres wide and a maximum of 1 metre deep. And they can either be have an open top, or they can be covered by some sort of suspended pavement. And these trenches need to be designed on arboricultural principles, such as the same as for tree pit, including the provision of under drainage. Another option is, as I said before, is extending the rooting zone below pavements. In urban areas, we have highly compacted soils, which are required to support pavement loads, but these actually limit the ability of the tree roots to colonise the soils. So there are three main approaches to extending the rooting zone below pavements. One is suspended pavements, structural soils, and plastic root cells. All these approaches are quite expensive. They can be cost effective in confined urban situations where tree planting is mandated, which is mainly in sort of capital cities. So if you really do have to plant trees, this may be the only way you can go. Suspended pavements, that's basically a pavement which is designed to span across the tree pit or the root trench. That's usually done with a thickened or a reinforced slab, so it's most appropriate to a narrow root trench where you can quite easily span that space, and you might have a gap between the slab and the soil, which allows a bit of aeration, etc. Here's an example of Chatswood Mall in Sydney. This was presented at the TREENET conference a couple of years ago by Arteria Design. So they provided a very large underground space with reinforced piers filled with soil, then a slab poured over the top of that, and a tree sort of installed in that space. So they provided a huge sort of rooting volume for that for those trees. I think they convinced the developers or the property owners to plant less trees but plant large trees, and actually provide the conditions to allow those to grow. So obviously this is a very expensive sort of way to plant trees. The other option is to install structural soils. The term structural soils applies to a whole family of engineered soils, not just one soil type, which attempts to overcome that problem of how do you provide engineering support for pavements at the same time meeting the biological needs of trees, which is to grow in uncompacted soils. And structural soils comprise a family of soils rather than a single commercial soil, include natural compaction-resistant sandy loams, sand-based Amsterdam tree soils, lightweight porous aggregate mixes, and crushed rock and soil mixes, which are known as gap-graded soils, which are the ones you sort of read most about. So these rock-based soils, so they're the ones which are most widely known, where you have a matrix of rocks and the voids which act together to support the pavements, and the voids between those rocks can be filled with loose rootable soils. Best known variety of this sort of skeletal soil is the CU soil, which was developed in the 1960s by Grabowski at Cornell University. And this sort of mix, it has 80% crushed stone and only 20% clay loam soil, and it's mixed in a rotary mixture prior to delivery and installation. So you can get these sort of soils in Australia or have them prepared. One of the best known ones is Benedict Soils in New South Wales, who have a number of different sort of structural soil mixes. There's been a critique of these rock-based soils in the last few years. Once again, here's this image from the Bartlett Tree Research Lab. The main problem with rock-based structural soils, the trees grow really well for several years, and they sort of exhaust the resources within the soil, which is only 20% by volume of the total area, of the total volume. And after that, the trees struggle to survive. There are other issues as well. How do the tree roots grow within those rock voids? Do they have the fertiliser and other resources for long-term growth? Space soil is an interesting product developed by David Laurie in South Australia. I don't know if you know David, but he's been quite sort of sick lately. He's had some sort of serious operations, but this is sort of his idea, which is it's a structural soil that provides 100% rooting volume as opposed to 20%. And it's made up of colloidal waste products from South Australian reservoirs, and has a number of desirable attributes, including low bulk density, low penetration resistance for roots, high structural strength, high cation exchange, and the number of successful trial sites around Adelaide where this has been installed. So an example shows the Franklin Street bus station, which was done about 5 years ago. It was a challenging urban site where they wanted to plant trees in a very hostile environment. 12 spotted gums were planted in a large tree pit, which was actually 60 metres long by 6 metres wide and varied 600 to 800 millimetres in depth. This is filled with space soil and paved over with open jointed pavers. It's just some images of that. That's the excavated trench, which was quite shallow because it was over contaminated soils. The structural soil was placed, spread, then it's compacted. So the soils were quite allowed to get wet, so compaction wasn't ideal in this situation, but it hasn't actually affected the structural strength of the soil. So the structural soil was installed, bedding sound was installed over the structural soil, tree pits were marked out, and that was a completed project about 5 years ago. And this is sort of today, those trees are really thriving. And the pavement's still stable. It's just a pedestrian pavement, but it's quite a successful project. The other option is plastic root cells. These were discussed earlier, that they've been sort of developed intensively over the last 10 years. They create instead of a rock matrix, they create a plastic matrix of plastic cells which can be filled with loose, rootable soil. There are two systems currently marketed in Australia. One is Citygreen, which has the strata root cell, and the other is the Deeproot Silva cell. And the Citygreen product seems to be the one that's come across most in the sort of tree projects in Australia, whereas the Silva cell is the dominant product in the United States. So the Deeproot Silva cell has large cells similar to milk cartons, milk crates. Citygreen has the strata cell. It's just some examples. Langtree Mall in Mildura. Some of you here would be more familiar with that project than I am, but it's an example of where the root cells were installed for a pavement, also to incorporate water-sensitive urban design practices. Victorian Square in Adelaide, that's a local example where the strata cells were installed. So it's the cells being installed in the ground and filled with loose soil. Then the surface was applied to that soil volume. And that was the sort of finished product. Project which I was involved with recently, which is a current project, is in Morphett Street, Mount Barker, where we combined structural soil cells with rock-based structural soils. That was mainly to bring down the cost of the project. So we dug sort of large trenches, and where the trees were installed, we used the Citygreen strata cells. And between those cells we installed trenches with structural soil. Another option is root vaults and bunkers, which Andy mentioned previously. You can create a giant pot for the tree, I suppose, which has a number of advantages in that it separates the tree from the surrounding infrastructure. Once again, it's very expensive, and it requires design based on arboricultural principles of water supply, drainage, etc. Something similar. This has been done in Adelaide recently in the upgrade of Rundle Mall, where the trees are planted in giant pots. Third sort of area of practice which I'd like to look at is how do we provide trees with the resources for growth when planted in sort of confined urban situations. So urban trees face additional challenges compared to those in open situations, including increased evaporative demands, the hot, dry city, and also restricted water supply compared with the open planting situation. So a number of recent practices have been developed to meet the water demands of urban trees, including porous surfaces, diverting stormwater runoff to trees, and actually incorporating trees into wider sort of water-sensitive urban design initiatives or systems. So Seattle landscape architect Richard Haag advocates what he calls the theory of softness, which really states that no ground surface should be harder than is absolutely necessary for its function, which is an alternative to what engineers like to do, which is compact every piece of soil they can see. And some people suggest that the same principle could be applied to permeability, that no ground should be more impervious than necessary. Once again, engineers, they want to make everything nice and neat and impervious and sealed. So porous surfaces can be installed over tree pits or tree root trenches, which enhances water infiltration and gaseous exchange. And there's a whole range of options: planter beds over the tree pit or trench, mulching, porous paving systems, porous asphalt, porous no-fines concrete, resin bonded gravel, which you see quite often in cities, and things like porous softfall or rubberised surfaces. So, and while these benefit the tree, they also have associated water-sensitive urban design benefits by reducing the volume of runoff to the stormwater system or to the urban waterways. Eco-paving systems. So once these sort of paving systems were only used for sort of light loads, but now we can design eco-paving systems which support vehicle loads. And there are two main types of paving systems: the ones which use non-porous concrete pavers that allow water infiltration through gravel-filled spaces between the pavers, such as the Eco-Trihex pavers, and other ones which the paver itself is porous, made of porous concrete material, such as hydrostone. And with these systems there are various options, as well as thinking about the tree. You can provide an underground storage layer where stormwater can be stored and reused for irrigation or other purposes. Some examples: Moore Park in Sydney, around some old fig trees, the Eco-Trihex pavers. Adelaide, Tim Johnson, I don't know if you've seen his work at various conferences. He's planting trees in, as part of his PhD research, planting trees in porous paving settings and sort of monitoring how that affects their root growth, and also what are the impacts on the infrastructure on the curbs. Uses sort of lasers to see if there's any distortion to the curbs in those situations, because, as you know, engineers don't like water being introduced into associated with anything that they do, sort of. An example: Sir Don and Bradman Drive in Adelaide towards the airport, using sort of rubberised surfaces there to increase the porosity around the tree. Hutt Street in Adelaide, that's a recent project by the Adelaide City Council. They had Hutt Street a number of plane trees which were struggling to actually become established and actually grow at all. So they had a trial of installing permeable paving over the actual, this is angle parking, so over the surface of the space where the trees are planted. So that was retrofitted to some existing trees, and also some new tree pits were installed with structural saws with permeable paving over the surface. So in that sort of situation, the actual permeable paving extends into the water table itself, so the water can infiltrate down into the tree pit. Another option is redirecting stormwater runoff to trees. So we all know that stormwater is a wasted resource. We tend to sort of put into drains and remove it from our cities and put it into the ocean. Why not retain stormwater? Why not retain rainfall at source where it falls? And divert stormwater runoff from roads and roofs to trees, which provides passive irrigation for the trees. It also captures that first flush runoff, which is the most polluted. So where trees are planted in the roadway or the parking lot, it's quite easy to redirect stormwater to the trees. Where trees are planted in the verge itself, another number of options have to be explored. This is an example of trees, a recent project in Whyalla, planting trees in the parking lane, excavating a large 2 metre by about 3 metre or 4 metre tree pit, and also cutting out a section of the water table. Just installing good quality loam into that space. And then sort of covering all that up with some sort of gravel surface, so the water can actually infiltrate from the water table into the tree pit. And they're very sandy soils at Whyalla, so there wasn't a concern with the tree roots zones becoming waterlogged. Infiltration trenches, more examples from Adelaide, Doncaster Avenue, just installing a situation with no curbs, installing an infiltration trench for the benefit of the some new river red gums. Infiltration pipes, there are various ways of connecting the kerb to the verge with infiltration pipes, channels, etc. Infiltration pits. This is Greenhill Road in Adelaide, trying to sort of revitalise some declining elm trees planted in the median by installing large aggregate-filled infiltration pits between the trees. And in this instance, they filled initially with water initially from a water truck, then in the longer term trying to install irrigation systems to water those pits. Another example, you actually have sort of pre-made infiltration pits or leaky wells, and this is, not only they're installing hundreds or thousands of these adjacent to street trees. They actually capture the water from the roof as it goes out to the water table. Some of it diverts into that diversion pit. The TREENET Inlet, that's another sort of innovation by David Laurie. If you've been to TREENET, you might have seen him giving demonstrations of this, and it's something which has been installed in a number of places nowadays, and also in Victoria as well, and other states. It's a means of redirecting road runoff to the verge or infiltration pits, to verge infiltration pits or trenches. So that's the inlet itself, which is designed to capture runoff without becoming clogged. And that connects to a infiltration pit in the verge. So just another view of the system, the inlet connecting to the pit and the verge. And these can be retrofitted into streets between existing street trees. The final thing I want to look at is the final option is including trees in water-sensitive urban design initiatives. So obviously one of those is bioretention tree pits. Probably Victoria is the place where this concept of bioretention tree pits has been most advanced in Monash University and through Melbourne Water. So I've got an example here from Adelaide. Bioretention basins, similar to the bioretention tree pit. Bioretention swales, Victoria Park in Sydney. Avenues of spotted gums planted in median verges, median planters with permeable curbs and biofiltration system beneath. So that was just to give a brief overview of some of those practices that I was talking about. In conclusion, I'd say that trees provide many benefits and large trees maximise those benefits. The tree should be an essential rather than optional part of the city. And trees need to be allowed to survive and grow to maturity to maximise the benefits they provide. One of the biggest constraints on tree planting is lack of space above and below ground. So when planning and designing urban areas, we need to sort of think like a tree, design around the biological needs of the tree. And I think I covered there's a range of best practices which have been developed in the last decade. Some of those in Adelaide, some elsewhere, which may assist in growing large trees in confined urban settings. Thank you.